next topic and next presenter, Yue from Bytedance will be talking about securing Bytedance with SPIFFE Inspire.
Thank you.
If you can stay closer, because like the mic is going from here.
I see. Hello everyone. My name is Qiao. I'm a security engineer from Bytedance. Today I'm going to share how we use SPIFFE Inspire to secure Bytedance and the challenges we think through the process and the solution we adopted. Before we jump into the technical part, I will have a brief introduction about our team, about who we are and what we have done. So who we are, my team is called the Zero Trust Infrastructure team within Bytedance, or ZTI team. And Eli is actually my ex-manager, and Ian is my current manager. And my team is responsible for providing authentication solutions for all products and services within Bytedance. I think Ian has covered a little bit. Bytedance have a very rich product line, which include popular applications like TikTok, Hotel, and Log. But I want to highlight here, we are also a public cloud provider. We are building our public cloud called the Volcano Engine. So what have we achieved? I think Bytedance built maybe the largest Spire clusters in the world. We have, in Bytedance, we have global data centers to support the large DAU of our applications. And we divided all the data centers into 4 trust domains. And in each of the trust domain, we have multiple Spire clusters. And each of the cluster contains like 10 to 100, maybe 100 Spire server instances. Please correct me if actually your company has a much larger larger scale than us. Yeah, I would be happy to share my experience with you and hear your feedback too. And also we integrate our identity provision flow with our major infrastructures. Yes, at Bytedance we have very rich infrastructure. We have fast platform, and also ICE platform. Like we have our own like Bytedance Kubernetes clusters, and also we have services running on virtual machines and physical machines. That's why Spire is a very suitable choice for us, because Spire support heterogeneous environments so well, and we deploy Spire agents in about 1 million machines. And at the service adoption side, we've already turned on token-based authentication for all critical services within one major region, which is actually in US. And we didn't push the usage of MTLs because the cost is a little bit heavy for the service team. But this capability is provided through service mesh. So more than 100 services have already turned on MTLs using service mesh because they secure their services. And because we did well in this major region, now we are moving forward to turn on all token-based authentication in all service-to-service calls globally. And this is working in progress. And this is a long journey to reach all these accomplishments. Actually, it took us about, I think, more than 2 years to this stage. And definitely we saw a lot of challenges through the process, and thanks for the SPIFFE Inspire community, which laid a very good foundation for us to make it happen. But still, we need to do a lot of customization to meet the real production needs. And for this section, I will just share the challenges and the solutions we adopted. The major challenges can be like divided into 2 parts. One is that the service side, which is mainly raised by our infra team, like say, if our infra needs to integrate with the identity provision flow, how reliable the provision flow is, right? And what's the latency of the identity provision? And at our client side, the service team, which will adopt those tokens and turn on authentication, they have I think richer problems. Like when we integrate our SDK, we see a lot of friction, especially in C++. I will explain it in detail later. And also they are concerned about the SVID availability, especially the trust bundle, right? If the trust bundle is broken or corrupted, then the service can no longer provide service anymore. That's a nightmare to them. And also we see a lot of like on-call burden, not because of the service bug itself, but rather like operational because you need to do a lot of manual identity registration. As I said, we install ZTI agents in 1 million machines, and also the number of services running on those machines are huge. So the identity registration would be a very heavy overhead to us. And also people just come to us because there are lots of OSN and OSZ failures. Just maybe simply because of misconfiguration of the OSZ policy, but our customers don't understand the difference between OSN and OSZ. They just say, oh, I cannot visit this service, and this says the ZTI token authentication failure or something, that they come to us. Then it consumes a lot of our bandwidth to address their problems, although it's not really introduced by us. So I will share the experience about that part too. Yeah. Okay, so the first problem is service reliability and latency. Originally, we thought that we want to adopt the native Spire approach at all places, right? For example, if our PaaS platform is built on a Kubernetes cluster, we say, oh, we can provide you a Kubernetes workload registrar, will help you automate the identity registration. And then the pod can use the SPIFFE workload API to get the workload identity from Spire agent using the native way. But apparently there's the first, because our scale is very large. Maybe just a medium-sized PaaS platform has more than 100K workloads running on top of that. And no one is sure that how large our Spire cluster needs to support such a large scale. And also there are a lot of latency here, like the workload registration process, and also the sync between the ZTI agent and the Spire server, and the sync between pod and the ZTI agent. And in some corner cases, like we also have edge data centers, right, where our Kubernetes cluster, our customers' Kubernetes cluster are running, and we cannot build a Spire server in every edge data center. So we need to ask the edge data center, the ZTI agent in edge data center to connect to the Spire server in main data center. So the connection between two data centers is horrible. It can take up to tens of seconds or something like that. Then it's not reliable. So the latency is intolerable in those cases. And also we have other cases like serverless or fast scenarios. There may be 100 process scheduled in one pod, and they are very dynamically created and deleted. So the native Spire cannot support such a use case. So therefore, we have to do some security compromisation here. So what we finally adopted is such a model. So we allow the PaaS and the IaaS platform to maintain their own identity service. We call it delegated identity service, which is joined in the middle. And this identity service can get its own Spire identity using the Spire workload API. This identity service is also working as a intermediate or signing authority to sign the tokens and the certificates for all the pods this platform or the workloads this platform are managing. So we are delegating the identity to this service in the PaaS control plane. And you can see that there are some security trade-off, right? Because the identity service is very powerful. It has a signing key. It can sign arbitrary tokens and certificates with arbitrary identity. So, but we feel like we trade off the security and the usability and adopt this model. And now we have 10 to 20 dedicated identity service owned by different teams within Bytedance. It's not very ideal. But the good news that we are working with infra team to migrating them to a more unified infrastructure. So we are basically saying we are shrinking our traffic computing base with that and this identity service. And next let's talk to the client side of the problem. So as I said, there are richer problems here. The top one is the SDK integration friction. So the most annoying thing for us in the initial stage of integration is that we found that the gRPC protobuf dependency is really hard, because in Bytedance there are so many different teams and they use different languages and their libraries. We don't have a unified code base. Say, oh, if you use gRPC, you must use this version. That's not true in Bytedance. And in C++, you know that dependency management is really a nightmare. So, and a lot of service team and library team do not use tools correctly. So it introduces a lot of conflicts at the client side. Another thing that as we are actually aiming to turn on service token-based authentication for all services, right? So integrate with each individual service is very challenging. It's not available. So our idea is that we should do this in the RPC level or in the service mesh level, right? If we want to do it RPC level, Bytedance has its own RPC framework. It's customized for Bytedance environment because we have our own traffic redirection mechanism or the load balancing mechanism. So we have our own RPC framework. But RPC team refused to integrate with our SDK because gRPC itself is the RPC, right? It's not logical to ask one RPC to depend on another RPC. So they say, oh, if you have gRPC API, we cannot integrate with you. Yeah. So therefore, we develop like two solutions. I will explain the first one first. The first one, yeah. The first one is file-based API. So idea is simple. So we just ask the ZTI agents or the fast control plane to inject the class bundles onto the pods. So if you want to verify the token, then you can just read the local trust bundle and do the verification. So this trust bundle is not sensitive data, so we feel like there's no risk there. And for the SVID, actually we reach out, we propose this gRPC issue to the open source community, and they directed us to SPIFFE helper saying, oh, you can use this utility to bypass the gRPC dependency. And this utility is actually something that can get SVID using the workload API and launch a process that can use that needs to use this SVID. But you can see this utility change the way of the service deployment. So this is very intrusive change. We don't want our integration to be so intrusive to our customers. It's not scalable. So instead, we developed our own util called SVID loader. It's just a sidecar process that can fetch SVID and write it into local disk or mount it as and this file can be mounted into the container as a volume. So basically every pod needs to run a sidecar container to help fetch the SVID. Still, we feel like it's a little bit too heavy, as you say. It's not ideal for every pod to run an additional sidecar container, right? Therefore, we developed a new idea that is called Spire CSI driver. So this one uses a delegated SPIFFE, delegated identity API, and also take advantage of the features of CSI driver. So when the pod is brought up, it can just fetch those SVID from its amount of volume, which contains SVID, which was provisioned by this Spire CSI driver. And we are glad that we propose this idea to the SPIFFE community, and we are glad they agree with our design. And we've already done the development, but we haven't open source yet. But hopefully, we can in the near future. Okay, and I finished the file-based API, but you can see that the writing trust bundle into local disk is secure, right? It's not sensitive data. But writing SVID in the local disk is not that secure because in non-containerized system. In containerized system, we feel like it's okay, right? Because usually we think that every access in every process in one container has root access, so it doesn't matter. And we can just provision one identity to one container. But on physical or virtual machines, many services and processes share the same environment. So it's not safe to dump the identity document there. So instead, we don't want to lower our security bar. So instead, we propose to add HTTP APIs in ZTI agent. And this way, we can get rid of the gRPC API and still achieve a similar security level. And we propose this idea to this community, the SPIFFE community, but unfortunately, they have their own concerns because they feel like the behavior of gRPC and the HTTP API may diverge in the end. And also, the HTTP API may expose a larger attacking surface. And there are some also technical issues like in HTTP API 1.1, there's no streaming support. So it may affect SVID update and revocation. Yeah, so we just implement this HTTP API in this agent in our own fork. Okay, the next one is SVID transponder availability. Although we've explained repeatedly with our customers say, oh, SPIFFE Aspire did a great work to achieve high availability because of the different layers of caching, right? We have caching in SDK, we also caching in agent, but they are still not satisfied. I think their concerns are valid, right? If anything is so many things can still go wrong, even if you have those caching. So for example, there may be some code bug in the dependency chain. And also maybe SRE did some misconfiguration. In the worst case, maybe they just erase all the transponder database, then no one has a transponder at all. So that's an extreme example, but this can happen. And we want to have some countermeasures to that. So what we did is to add an additional service called Downgrade service. Downgrade here means that we skip the signature verification of the token, but still allows the identity passing from the token. So that service can still get the identity and do the authorization as but the signature is ignored because maybe the transponder is not correct. So definitely we sacrifice some security in this case, but this only should be done in an emergency case as the last result. And also we have like fine-grained downgrade configuration, say, oh, maybe you should only downgrade for this specific service, or in the worst case, if the transponder is corrupted in the whole region, then we should do the global downgrade. Yeah, then the last part I would cover is the Oncall burden. As I explained in before, so the most Oncall burden come from the two parts. One is identity registration. One is helping people helping people debug their authorization or authentication features. So to address these two issues, we developed something called ZTI Portal. It's responsible for two things. One is self-serving identity registration, which allows the users to conduct identity registration with more automation. So they may pass through some approval flow with their leaders or something, and all they can just get the identity through some automatic permission. We will check, oh, this user owns this identity, so it's allowed to just fill its own identity registration entry. And the other responsibility of ZTI Portal is providing some self-diagnose tools. Like this portal, users can see whether the Spire agent are installed on these physical machines or whether they are healthy, and they can also check whether the registration entry is correct. And if all the things are fine, then maybe that's not just our problem. We should go to the authority team to see whether there's something wrong there. Yeah. So yeah, I think that's all I want to discuss today. And in the end, I want to maybe highlight the lessons we learned. So I think the keys to our success. Here, I think first we need to thank for the SPIFFE community for laying such a good foundation for us to build such a system, and also they value the high availability to make our life much easier, right? And beyond that, we value user transparency because authentication is such a low-level thing. We want to make it user transparent as possible. So we do it at a service mesh layer or mesh or RPC layer. But in some processes, user involvement is not avoidable. Like for services running on physical machines, they need to go to the registration process anyway. So we put a great effort to make the onboarding as user friendly as possible and make the whole system at low maintenance. Yeah, I think that's three keys to our success. Yeah, thanks.
Thank you.
Any questions?
I think we tap on time, but there is like one question in the chat. Will you open source Spire CSI driver?
When?
Will you open source the Spire CSI driver?
Yeah. So yeah, we found the design approval and we plan to do it, but because of limited bandwidth, we didn't have time to do it. So many works internally. So if you want to join our team, I will be very happy.
All right, thank you so much. So here's a call to action. If you want to help with Aspire CSI driver, find you or Jan, and you can apply for a job there and work on the open source. All right, we have a next presentation.